It's actually been a while since I made a new video, so let's see if I remember how to do this. Hopefully the dogs won't be barking or any weird clicking noises. So the new chapter we're doing is coast and coastline. Basically, we're ending where we started, which is back at coastal geomorphology. Hopefully most of this is review, but it's probably a review from a really long time ago. When we're talking about the coasts and it's important, your book says that 80% of the U.S. population has quote unquote easy access to the ocean. I believe that means it's within 100 kilometers or basically like a half a day's drive. Large amounts of the entire world live within easy access to the ocean. Something like 30% of people rely on food from the ocean as their primary source of protein. So clearly, the coast is a widely populated area that's really important. The ocean and the coast specifically get 10,000 waves a day that impact it. We're going to be talking about the physical and geomorphological features of the ocean. Those waves things become really important. And the coast is just important because we know it has a separate climate. It provides food, transportation, surfing, recreation, all sorts of things, including in a state like New Jersey, vast amounts of economic resources. So the coast is important. Now, the next couple slides are going, I'm not even going to read through all of them because I'm going to talk about them more when I get to the picture. So if you do that thing where you pause, you should probably pause now so you could like jot down all this stuff. And same thing on this one. And same thing on this one. So these are the pieces of the beach that you need to know. And terms like the beach actually have a specific meaning. So let's look at this diagram that's in your book. This diagram is wildly important. I cannot overemphasize enough how much you need to not only be able to, say, label this diagram, but eventually be able to draw your own. So one of the things you should notice is that this is the West Coast. I guess you could know it's the West Coast because for its coastline, instead of dunes, it has a wave-cut bench. So if you're on the East Coast, it would be very similar to this, except in this area, right? Let me grab a pen. That'll work. Except in this area right here. In this area, instead of a wave-cut cliff, we'd have dunes. And our berm area in here would be much, much bigger. That's kind of the defining characteristic of one of the eastern or depositional beaches, which we'll get to later on. You need to know most of these parts. So let's start with the coast. The coast is this area right here. Okay, it's basically from the coastline all the way out to an undefined point. Basically, the coast is an area of geographical features that is influenced by the ocean. Can be anywhere from 1 kilometer wide to tens of kilometers wide. So it's a pretty big area. Right to the shoreward of the coast is the coastline, which is the line between shore and coast. I guess we should jump right into the shore. The shore is this area basically from the low tide line all the way up to the coastline. And I guess I could draw here, like this whole area here would be shore. And the shore is everything that is influenced by wave action. So at low tide, this area is influenced by wave action. Typically, this area is by high tide. And during storms, this area. So that's the shore. And I kind of do coast and shore first because everything else kind of backs up off of them. The shore is further broken down into two sections, the foreshore and the backshore. There's this weird saying that helped me when I was still an undergrad. It's don't be funny now, DBFN. D was dunes, B was backshore, the F part, the funny, is foreshore, and the now is nearshore. So if it helps you, great. If it doesn't, don't worry about it. The foreshore is the area that's basically the wet sand from the low tide mark up to the high tide mark. If we were doing this in another classification system, it would be called the intertidal zone or the littoral zone. But when we're talking about just land forms, it's the foreshore. The backshore is basically like where the bennies put their towels down when they go to the beach. It's from the high tide shoreline. It includes the berm and it goes all the way up to the base of the dunes. In this diagram, the backshore is super small. On our beaches, the backshore is actually quite big. So far we've done coast, shore, foreshore, and backshore. Nearshore has a couple of things going on. It's basically also known as the breaker zone. It's where waves begin to break until they get to the low tide mark. So the nearshore is this whole area in here. And within the nearshore, there are a couple of features. You're going to have a longshore bar and a longshore trough. The longshore bar is an area of sand, or basically a sandbar, and it's what causes, especially on depositional wide beaches like ours, it's what causes the waves to break. Almost all beaches have a longshore bar. Right in front of the longshore bar is a trough. Sometimes when you go to the beach, the trough can be like really deep, like 2 feet, and then you got to jump up onto the bar. But both of those will be found in the nearshore zone. This wave cut bench that's right here is a feature of rocky beaches that you see on the west coast. You will not actually see one of these on a depositional beach like ours, but it's always in the diagram. I clear everything off. Then there's the offshore. Offshore is basically open ocean. It's from where the, you see the rollers come in, but before they actually break. There's the magical line right here. If the waves are not breaking, they're offshore. Once they begin to break, they're in the near shore. And that's kind of how you know those. Now, together, the near shore and the shore, which means it also includes the foreshore and the backshore, is the technical scientific definition of the beach. This is ocean. This is land. And the beach is basically from the base of the dunes out to the sandbar. And I bet you probably didn't know that. We call the whole thing the beach. There's a couple other things in here that you could see. We did longshore bar, we did longshore trough, we did the wave cut bench. The beach face. The beach face is actually the sloping part of the beach that goes from the low tide mark to the high tide mark. The berm is the crest. In a beach more like ours, you'll have a very long beach face and a steep berm, and then we go back down. That would be the berm right there. And on an erosional coast, like we see in this picture, you would also have what's called a wave cut cliff. And there's a whole set of features associated with that specifically that we will learn about later on. Oh. The beach itself is made of materials that vary depending on where you are. So when in beaches like ours where we have sand, we have 4 major components to our beach sand, which are all local materials. We have granite, we have quartz, we even have a little bit of magnetite, which is magnetic, the little black specks in the sand, and so on. Did I hit all of them? I think so. This is why if you go to different parts of the country or the world, you have different beaches. Some of you have probably been down to the beaches near Hilton Head or Key West, which are made of primarily like a biological component like we have right here, where it's a shell beach. There are famous places in Hawaii which have black beaches or green beaches that are made either from just obsidian or oxidized lava. If you are at an area that is heavily dominated by rivers, like if you've ever been to the beaches down near the Chesapeake, they have very, very fine sediment. Even here down in Cape May, as some of you have been recently, the beaches there have super fine sand because the Delaware River, some of you were there recently too, has super fine sediment due to erosion. And then if you're on the West Coast where they have cliffs, even here on the East Coast, like in Maine, you can kind of see it in the background picture. If you have that kind of coarse material and the major part of the beaches comes from local erosion, you're going to have a coarser sediment. So that's kind of where all the different materials come from. The Wentworth scale, all the Ocean Bowl kids kind of know this to some degree. Sand is actually a size, not a material. I think a lot of kids struggle with this. They think sand is a material. All of these terms in here, whether it's a boulder all the way down to clay, those aren't materials, those are sizes. So boulders are bigger than about, 256 millimeters, which is like maybe a foot across. And clay and silt are very fine particles. What they're made of is sort of irrelevant. It's basically the size. I don't really need you to memorize any of this except for I just wanted you to know that sand is this super, basically anything from 2 millimeters all the way down to 1/16 of a millimeter sand. Silt and clays are finer than that. And then we have all these things from a granule up to a boulder. Bet you didn't know a cobble was a specific size thing. And that's kind of it for this video. See, not too long.